Hi, Nur Alam and Miss Lili. We are from Group 17. I'm Christopher Verrell and I'm with my group mate, Verena, Vynne, Sentosa. Today we are going to present to you our research poster with title Reducing Overcrowding on Public Facilities by using crowd counting using convolutional neural networks. This research focuses on how we can use artificial intelligence, especially machine learning, on predicting the crowding at public space effectively. And before we get into deeper research material, we should know that what kind of problem that we try to solve in this research. So crowding is an unconducive situation caused by the large number of people in a place. This happens frequently in public facilities like city parks, bus stations, and during music festival and concerts. And this kind of overcrowding can lead to safety hazards, discomfort feelings, and inefficiency in spaces utilization. Crowding is usually caused by poorly planning and lack of effective organization management because they can implement the rights of crowd monitoring and crowd management. And this kind of crowd monitoring we want to implement using the crowd counting so that the organization can help to improve public safety and event management. Therefore, it is important for authorities to implement crowd counting for predict possible risks and take mitigation effectively. Our paper proposes a crowd counting detection program. This application can maintain about the amount of crowd in a place so that people can predict first what kind of situation in that place happen at the moment. And it will it will output a sound trigger when the capacity is reached the maximum threshold that we initialize in that place. Okay, next, what kind of methodology we use to approach in this program? So our program uses CNN approaches to detect and count crowds in public. To achieve effective crowd counting, our methodology involves by 5 steps, which are data preparation, preprocessing data, model architecture that we use, training and validation, and lastly, we will evaluate our train model. And the data preparation, we would take the 2000 images from Kaggle platform that posted by Francisco Mena. So Francisco Mena has posted these images contains with CCTV's angle from a mall. So this kind of images really suitable for our goals because we want to see the crowd from upper hat visitors angle. Second, we have pre-processing data. We will pre-process our data to involve resizing each image to 224 times 224 pixels to standardize them. And this pixel would be normalized to range 0 to 1. So we can guarantee they are suitable for model processing. And next, we have ResNet 50 model architecture. This is a pre-trained model that have been pre-trained using ImageNet. And we want to custom the fully connected layers, including a flattened layer, a dense layer with 1024 neurons and value activation. And finally, we will use output layer for continuous value prediction. Next, for the training and validation, we will use the 20% from the 2000 images from the dataset and testing the dataset to validate the model's performance. So maybe we not mentioned before, the 80% from the 2000 images we will use for the training model. And next, finally, we have evaluation. We will use mean absolute error as our measure of the model's ability to predict. And evaluation will be due by changing the numbers of learning rate, epochs, and bed size. So the result will be explained by my teammate.
Okay, so the next one is result and analysis. To implement crowd detection, our study uses Python 3.10.12 with the help of Google Colab. So our study uses the OS model to interact with the operating system and also uses the Pandas, NumPy, scikit-learn, and TensorFlow class libraries. We optimize the model by experimenting with learning rates of 0.0001 and 0.01, epochs of 10 and 20, and batch sizes of 32 and 64. We evaluated the model's success based on the loss and the MIA values. Therefore, we conducted a series of 8 experiments to optimize our crowd detection model. In experiment 1 to 4, we used a learning rate of 0.0001, And in experiment 1 and 2, we trained the model for 10 epochs, while in experiment 3 and 4, we trained the model for 20 epochs. Experiment 1 and 3 use a batch size of 32, and experiment 2 and 4 use a batch size of 64. In experiment 5 to 8, we use a learning rate of 0.01. Experiment 5 and 6, we trained the model for 10 epochs, while in experiment 7 and 8, we trained the model for 20 epochs. Experiment 5 and 7 use a batch size of 32, and experiment 6 and 8 use a batch size of 64. So you can see the result of our experiments in the table of loss and MIA displayed on our poster. This chart provides a clear comparison of how different learning rates, epochs, and batch sizes impacted the model performance across all 8 experiments. So therefore, after analyzing all these experiments, we found that the best configuration was a learning rate of 0.0001, 20 epochs, and a batch size of 32, which is experiment 3. This setup produced the most accurate result with a loss value of 0.0192 and an MIA score of 0.109. This suggests that a lower learning rate ensures stable and accurate learning. Increasing the number of epochs allows the model to learn more effectively. While batch size has a minimal overall impact, it is crucial to balance these parameters to achieve the best performance. In conclusion, our research shows that using CNN ResNet 50 for crowd counting can effectively manage and reduce overcrowding in public facilities. By optimizing the model's parameters, we can achieve high accuracy and reliable prediction. So this crowd counting program can significantly enhance safety and also comfort in public places by preventing overcrowding and maintaining capacity limits. That is all from our presentation. Thank you for listening.